And it's a pleasure to kick this off. As many of you know, if you're at the first one, this is the inaugural season of the Nexus lecture on water. This is the primary reason that we're here. As most of you know, because most of you work in the water area on campus, it's one of the strengths of the campus. And hopefully it's going to grow as a university. A lot of this kicked out from the NERT grant we got a couple of years ago, I guess, and has really contributed to the UN Bridges program. So a couple things I really want to do is I want to thank the people, Lisa and Teresa, that helped put this together, and the people that helped fund this, the Flat Station, the LBS, UN Bridges program, and mostly my office. So. I had a great dinner last night. So go ahead.
Okay, thanks, Pat. So my name is Andrew Wilcox. I'm one of the co-leads of the UN Bridges program, and that is a national research traineeship, NERT, which Scott referred to. That's a National Science Foundation funded graduate training program that is oriented around questions at the nexus of food, energy, and water systems. So that is the nexus we are referring to here. And Nancy is one of our distinguished visitors this year. Stay tuned for more great speakers next year. In addition to the sponsors that Scott mentioned, the Office of the Provost is also a sponsor of this talk. And the presentation today is being recorded by Missoula Community Access Television as part of a media assistance grant donated to our organization by MCAT. So to introduce Nancy, Nancy Grimm is an ecosystem ecologist and interdisciplinary sustainability scientist who studies interactions of climate change, human activities, resilience, and biogeochemical processes in urban and stream ecosystems. She is a professor at Arizona State University, and for 2 decades, from 1997 to 2016, she led an LTER, long-term ecological research program oriented around central Arizona and Phoenix. So we'll perhaps hear some stories from that today. So that was a really important interdisciplinary study that brought together sort of urban ecology and a complex metropolitan region with some broader ways of thinking about social and ecological systems. She now co-directs the Urban Resilience to Extremes Sustainability Research Network, and she works with cities to co-produce visions of resilient and sustainable futures. She has a long list of accolades, fellow of many important professional organizations, AGU, ESA, where she's a past president of Society for Freshwater Sciences, and AAAS. She is an editor and has been editor for a number of journals. And as I mentioned, now she is at Arizona State, where she is the Virginia Ullman Professor of Ecology in the School of Life Sciences and Senior Sustainability Scientist in the Wrigley Global Institute of Sustainability. So without further ado, I'd like to turn it over to Nancy, and as a reminder, we'll have our reception outside here afterwards, so please stick around and chat. Thanks.
Yeah. Glad to see everyone here. Thank you so much. Thanks for the weather. It's really a real change for me, actually. I'm not going to. I wanted to put Miami on my slide so you would see a place that has some water. Where I work, mostly there isn't any. But anyway, I'm going to talk to you today about, particularly about extreme events, and how cities will respond. So most of what I want to tell you about is really recent work that we're doing on thinking about cities of the future and how they can cope with climate change and disturbance. But I'm going to start by pontificating about some sort of things that ecologists think about a lot. And I'm going to turn, okay, I hope it's okay that I turn the lights off because I want you to be able to see pictures and stuff. So, okay, so to begin, I want to thank my collaborators. I work in many interdisciplinary teams, but I want to especially thank the people who've been involved in the research and actually, in reality, teaching me how to do the research that I'm going to talk about. And you can see the numbers here correspond to pictures. Marta Berbes, Elizabeth Cook, Melissa Davidson, David Iwaniak, Timon McPherson, and Tisha Munoz Erickson. of two of these people were in our IGERT program, which is like your NRT years and years ago. And all the people that are in the UREX program and 20 plus years of KEP LTER, but I want to especially call out Chuck Redman, who is over here under the Mexico sign, and he was the guy that dragged me into urban ecology in the first place. Okay, so, oh, and I need to thank funding from NSF, and again, these are the two programs that I've mostly been involved with for this work. I'm not going to talk at all about my stream biogeochemistry research, but I'm happy to talk to people one-on-one about it. Okay, so I'm going to start off by talking about the cities of today and how they are facing extreme challenges in the Anthropocene, particularly the collision of various global change drivers. But then I'm going to spend some time talking about what we mean by extreme events, what we mean by disturbance, what we mean by resilience, and when we work with people in cities, are they talking about the same thing that we're talking about when we talk about resilience? And after I go through that, I'm going to go to the second part of the talk, which I'll introduce later, where we'll talk about this approach to thinking about resilient and sustainable urban futures. People want to sit in the front, there's chairs. I won't mind at all. All right, so we're living in an era in which nothing is stationary. That is, things are changing all the time. And this is an example of one of the things that's changing. We know that the climate is changing, but we don't often think about what that means for extreme events. And this is a graph from 1950 to about 2017 showing the increase in natural disasters, many of which are driven by climate change, or many of which are related to climate. As you know, we can't say anything about a single disturbance event and how it is caused or not by climate change, but we can certainly look at the suite of and massive changes in the number of extreme events and say something about how that's related to climate change. Cities, because they're located along coasts and often in areas, inland areas that are subject to drought, and also because they concentrate populations of people and also infrastructure, are particularly vulnerable to extreme events. And this is a picture from San Juan, which is one of the cities that we study, post-Maria, which happened in October of 2017. You can see quite a bit of destruction there. At the same time, cities are on the rise. So we are living in this sort of urbanization transition. This is 1950, a little before I was born, when there was just, I'm going to go back, sorry, 106 cities over 1 million in population, and just one city over 10 million, a mega city. By 2010, or present day, 47 megacities, 15 of those in China, and 450 cities above 1 million. So this is an explosive growth of cities. And then by 2030, projections are that there'll be something like 2.5 to 3 billion new urban inhabitants, and much of the urban growth that we see worldwide is going to have occurred in the global south, in places that maybe have a little less financial capacity to build infrastructure and so forth as cities grow. So what we have is a collision course. We have a climate change and urbanization on this collision course. And I would argue that people, most people in the world, who are now over 50% living in cities, experience climate change most immediately and urgently as a result of extreme events. That's when people sit up and take notice and say, climate is changing. And infrastructure is a really important component, particularly in urban systems, of what the defense is against those kinds of extreme events. And I'm going to define infrastructure here as the physical components of interrelated systems that provide commodities and services essential to enable, sustain, and enhance societal living conditions. All right, that's a definition that comes from Newman and Smith in 2010. Well, let's just back up for a second. And when I say city, what do you think of? When you think of a city, you think of something that might have some kind of infrastructure. It might have some tall buildings like you see back here, lots of houses, these streets that have trees along them. And we think of infrastructure as including all of that. So it has ecological, built, hybrid, and institutional features that are managed in some way by people. So that's a sort of an enhancement of that definition. So infrastructure is essentially a very fundamental component of urban social ecological systems, so much so that we have begun referring to cities as urban social ecological technological systems, or SETs, in which the final S, systems, is a very important thing for us to remember. So we want to remember that those things are all interrelated and interacting. So urban infrastructure provides protection against hazards and potentially provides additional benefits, and sometimes provides some disservices in this case. So the challenge that I'm laying out here, which is the collision of climate change and urbanization, is what we would call a wicked problem. A wicked problem being one that requires a greater integration of different perspectives, disciplines, sectors, and so forth, diverse expertise, and often is conducted in a transdisciplinary setting. We talked about this a lot today when we talked about the science-practice interface. So I think these kinds of wicked problems really require us to be very attentive to that interface. One wicked problem is really how we can transform today's cities and the cities that are coming up in the future into places and communities that are resilient. So we're going to talk about what I mean by resilient systems. But this is just an amazing photograph to me. This is a photograph post-Maria, and this guy right here is on a bicycle riding through this just incredible destruction. Okay, so given this background, we established this network called the Urban Resilience to Extreme Sustainability Network. This is the network here. You can see the cities are listed. We're focusing on 4 types of extreme events, so coastal flooding, extreme heat, drought, and urban flooding. We have these Latin American and continental US cities, and we're interested in how different cultures and different backgrounds actually approach the problem of dealing with extreme events and resilience. And we have an important component of an educational component with graduate students and postdocs and so forth. And we are about 4 years into this 5-year project, even though I say it goes till 2021. That's if we have any money left over for a 1-year no-cost extension. So yeah, we're pedaling hard, let's just put it that way. Okay, so that's the backdrop. This is the group that's working together on this. One of the first things that we asked is, when we talk about extreme events, what do we mean? What do we mean? I think, as an ecologist, I think this is related to the ecological concept of disturbance that I've worked on since I was a graduate student. But there are many other ways to talk about extreme events. And so we pulled together, and this was work led by Lauren McPhillips, who is a postdoc and now is at Penn State. This sort of pulled together literature from 6 different disciplines. We binned the literature into those 6 disciplines. We looked at 244 different papers, and this is just showing you the top 10 words used in those 6 different disciplines. And the colored ones are ones that are shared with at least one other discipline. And one of the first things to note about ecology, how many people here would say you're an ecologist or closely related to an ecologist? Okay, not as many as I thought, but notice in ecology that there's many fewer colored bars than there are for others, and the top word is disturbance. So just to think about disturbance, this has been a huge area of research for ecology for decades. It's a really important concept in ecology, but what do we mean when we talk about disturbance in urban ecosystems? When I first started working in urban ecosystems, people would say to me, oh, you work on those disturbed systems, right? So the system itself is a disturbance. The fact that there's a city at all is a disturbance. Well, we don't think that's actually true. So what we wanted to do was to think about the theory of disturbance in ecology, and this is one of the first definitions that was used widely by White and Pickett in their book in 1985. So discrete event is important, disrupting ecosystem, community, or population structure, and changing the relationship of resources to organisms. A simpler definition by Pickett et al. In 1989 was a change in the minimal structure caused by a factor external to the level of interest. Well, this is interesting in urban systems. What is minimal structure of an urban system? That's an interesting question to ask. Okay, so what do we mean by urban disturbance? It's certainly not the construction of a city, although there are some disturbances of ground, for instance, associated with building a building. What do we really mean when we talk about urban disturbance? And so a group of us here, Stuart Pickett, Rebecca Hale, Mary Cadanasso, and I worked on this question, published this paper last year, 2 years ago, and asked the question. Now, when I showed you that picture and you look at this, you can say that's a disturbed urban system, right? No question that there's disturbance that's happened there. So something has changed. There's some change in the minimal structure of that system. And remember that I said that I think structure in urban systems is also very much tied up with infrastructure. And so if we think about it, the components or the minimal structure of that system has elements of the ecological, biophysical domain, elements of the technological, infrastructural domain, and elements of the social and behavioral domain. So some people may have been hurt by this, and that is a change to the minimal structure of the system. So we're using this framing, which we call the sets framing, in our work, thinking about interactions between all three of these domains in the work that we're doing. And there are a few papers that have come out that sort of lay out this sets framing, if you're interested in looking at those. So the most fundamental requirement, we think, for understanding disturbance in a system is to understand what is being disturbed and then what is the event and the mechanisms by which that thing is being disturbed. So understanding the minimal structure is important. So this is the framework that we borrowed from a paper by Deb Peters and others, published in 2011, that Stuart was an author on. And it just simply takes the event, the impact, and the recovery or reorganization as three separate parts of a disturbance process. Each of those may be influenced by drivers. The disturbance has particular mechanisms that operate on the system with its properties. There's some changes that leave disturbance legacies, which are a function of the system after the disturbance, and then can feed back to creating a different starting system for the next disturbance. How that reorganizes and changes and the new state of the system is a function of these kinds of internal processes and drivers. The important thing that we tried to do here in this urban disturbance paper was to say, all of this can apply, but these drivers and processes and disturbance mechanisms can be social as well as ecological or as well as biophysical. So here's an example, just one example from this paper. This is the Great Recession 2008. Hit Phoenix pretty hard because Phoenix is all about construction of new homes. That's what growth in Phoenix. So there were many places that were left abandoned as people moved out, went foreclosed on their loans and so forth. So if we try to put this sort of idea into this disturbance framework, we can take this and say the event is this housing bubble that leads to an economic downturn, leading to mechanisms of abandonment and foreclosure in many homes in this area. This is the starting system here with a population that's growing and moving around a lot, selling homes, buying homes, et cetera. And the impact here is that we have this abandonment, and so we have people leaving homes and not managing those homes any longer. And then we introduce this idea that we actually have these ecological drivers and processes that come in, so plants establishing in these neighborhoods. And if we just look at what happens, the system results changes to one in which The vegetation is weedy species that are invading from neighboring plots or from the desert, and really big changes that were measured in these residential landscapes. So this is based on a paper by Julie Ripplinger and others. But the point is that we have these structural changes in the system that were initiated by a social disturbance and resulted in ecological changes. And we could think about many examples that would go the other way. All right, so that's sort of where, it was just a little bit of a diversion to talk about ecology and disturbance theory and how it might apply in urban systems. Going back to our what do we mean by extreme events, remember I said these 6 disciplines had differences in terms of the kind of ways they were classifying what or talking about extreme events. Ecology and climate science are over here, pretty far away from social science and so forth. So in that paper, we came up with this idea that we have the event, the impact, and the response. And the words that different disciplines are using to talk about extreme events are plotted there, so that you can see that where climatology is primarily focused on the event, social science is more focused on the impact and response. And so some of the words that we use there, like disaster and manage, adapt, and change, are things that have more to do with what social scientists are thinking about. One of those words is resilience, right? So resilience is this idea that there's a response that allows us to sort of come back into change systems and either recover or bounce forward or something. But what do we actually mean by resilience? This is a very simple framework that comes from somewhere in the IPCC. I'm sorry I don't have the citation here. But the idea is that you have these climate change that results in extreme events that present a hazard, and you have social patterns and processes that set what kind of exposure, sensitivity, and hence vulnerability a population will have, and this leads to risk. And risk is a product of the likelihood of an event and the consequence of that event occurring. The problem with this is it's pretty mute on the responses, what kinds of responses there are, on adaptive capacity, on the ability to learn, grow, and change, to innovate, and to reduce risk. It doesn't really have a systems lens, and it also doesn't take into account the fact that our probabilities of events occurring are changing all the time. So we live in a non-stationary world where the probability of what might be today a 1% probability flood might in 10 years be a 10% probability flood. So we use a simple, straightforward definition. Cities and their infrastructure are resilient when they can persist, adapt, and transform in the face of stress and shocks, while maintaining their structure, function, identity, and feedback. So this is a simple but somewhat egg-headed definition of resilience. It's fairly straightforward. But again, we need to think about what is structure, function, identity, and feedbacks in an urban system. And this, I think, needs to include these social, ecological, and technological components. I think in urban system, we place a pretty high value on persistence. So we place a high value on the New Orleans continuing to be New Orleans following Katrina. And we have an important idea about how what adaptations society can actually exhibit. But what constitutes failure in this case? Unclear. So we also wanted to ask, what do our cities actually think about resilience? And so this is a word cloud. You know how these work. These give you the largest word is the one that's used most frequently. And so I've just translated these because this is from Valdivia, Chile, so they're in Spanish, but into this group of words. And what's interesting here is that there's more to it than what we talked about in our simple definition. There's the idea of live and prepared and forward, some interesting ideas that come out of cities' ideas about resilience. This is one city. It's a small city in Chile that is subject to earthquakes and flooding. here is Phoenix, Arizona. And so there are some words in common with Valdivia. There are some ideas about change, infrastructure, adapt, prepared, but also ideas about water and heat. No surprise there because this is a desert city. Future, adaptable, etc. So we've also, in our discourse with practitioners, we've adopted resilience definition coming from the Rockefeller Foundation. The Rockefeller Foundation has a big program in 100 cities across the world where they're trying to help cities develop plans to become more resilient. So we're using that definition, and it's a little bit loosey-goosey compared to the ecological one. But you know, for example, this paper by Susie Moser that came out in 2019 talks about resilience as a contested idea. So people have really different ideas about what it is. Some people, and I would say ecologists are probably in this camp, think that resilience is a system property. We can simply measure characteristics of the system that tell us whether it's resilient or not. Some people think of resilience as a process, and some camps think of resilience as the outcome, what we're actually trying to get to. So I think it's clear that there is a diversity of different uses for this term. And interestingly, our practitioners, when they talk about resilience, they want to talk about equity because they think they haven't been paying enough attention to equity. Now, I would say, you know, as a sustainability scientist, that's sort of part of sustainability. But if you want to talk about it in resilience, here's what I'm going to say. I think, you know, we just need to really suck it up and talk about things in terms that others can't understand in the ways that they're thinking about it. And so we're not going to get into arguments with our practitioners about what resilience is. Instead, in fact, we might not even use the word, but instead we're going to talk about this sort of general idea of cities being able to be flexible, being adaptable, having these characteristics of redundancy and learning and innovation and those kinds of ideas that go along with the idea of resilience. Okay, that's the diatribe about about disturbance in ecology and sort of where we come out as really contributing to this whole area. And I think we have a lot to say. I still believe that ecologists have, you know, a lot to say and should be at the table and should be talking about these kinds of things. But I just want to caution that we need to be really careful about not insisting that our theories and our terminology is adopted by everybody. All right, so now I want to talk about what we're doing, working with these cities to try to think about how they can become more resilient and sustainable in the face of this challenge of increased urbanization and increased extreme events. So I'm going to talk about work we do in analyzing vulnerability in the cities, what some of the social, ecological, technological strategies are and how they can actually provide ecosystem services. I'll spend most of the time talking about positive future visioning and our approach to that, and how we visualize these various kinds of data sets, and then how we actually assess the resilience, primarily resilience of these future visions. So we really have a situation right now where you can find any number of narratives about the future, but they're almost all dystopian. These narratives are really all about gloom and doom and how we're headed for disaster. And these are just a couple of examples of gloom and doom future scenarios. But this is really a barrier to thinking about the future and planning for the future if you think, oh, it's just all going to be a mess. So instead, I think what we really need to do is to be thinking about positive futures. So this introduces into the process of thinking about a future a normative component, and there's really no way to get around that. It's really important to do that, I think. So we know we're trying to establish what we know right now about cities, and we can do a lot of projections and modeling are focused on this. What could be? So what will happen if we stay on this same trajectory? And there are many models that are sort of modeling what the future is going to look like. But what we're trying to introduce is this idea of what should be. So an idea of what do you want Missoula to look like in 2100 when your grandchildren are running around here? That's kind of what we're really trying to think about. And this is a really important approach for several reasons, but one of the most important ones is that many of the things that we face today as big challenges are things that were solutions of the past, right? So I'm going to give you some examples, and I'm sure you can all think of some too. In the West, we have a lot of introduced fish species that have pretty much extirpated native fish species through hybridization, through competition, and various other reasons. But somebody thought it was a great idea to introduce these fish so that we would be able to fish for bass or whatever in waters in the West. That's a great example of a solution of the past that has become a problem today. Here's another one. Katrina. There was a shipping canal built in New Orleans which was meant to bring the port closer to the city. And that shipping canal took a long time to be built, and by the time it was built, the ships had outgrown it. So it was not useful as a shipping canal at all. However, it was extremely useful as a conduit for sea surge to come in during Katrina and flood major portions of the city. So there's another example. And many of the examples we can think about, these solutions of the past, end up being problems today or have to do with things that we build, right? But my favorite example as a biogeochemist is the expression, better living through chemistry. No offense to any chemists here, but here's an expression that tells us that everything will be better if we can just sort of invent some chemical that's going to fix it. And now we're confronted with lots of chemicals that are in the environment that we don't really know what to do with. So that's really the reason why we want to be thinking about these positive future visioning. So here's what we do. We start with some diagnosis steps. We do this analysis of vulnerability. We send a survey out to all the potential participants in, or all the people that are involved in decision making about a particular area. And we do an analysis of governance documents. These documents are things like the climate action plan or the resilience plan or the general plan for the city. And we do a content analysis of those governance documents to come up with some of the things like you saw before. What do the cities think resilience is? But also things like strategies that we might be able to provide to participants in our scenario workshop that are ways to think about the future. We hold this workshop. It's an all-day workshop, and I'll show you a little bit what we do there. We have a lot of data that come out of that, which we are in the midst of processing. We can do qualitative and quantitative analysis of the scenarios. This is a qualitative analysis. This is a modeling output from San Juan. And then we can go back to those same participants and say, here's what the models are showing us resulted from this scenario that you created. What do you think? Do you want to go back? Do you want to change some things, et cetera? Okay, so starting with vulnerability analysis, I just wanted to show this. This is really good data that we happen to have for Phoenix based on the CAP-LTER. This left graphic here shows you income, family income, with the darker, browner colors being low family income and the blue being higher. So I'm highlighting these two areas. And what we see on this map is the colors are vulnerability to extreme heat, from blues to reds being most vulnerable. And here are those two rectangles. And the green dots are the number of mortalities associated with death. And there are quite a lot of mortalities in Phoenix associated with heat. associated with death. Associated with heat, and you can see that many of those high mortality rates are clustered in the low-income, high vulnerability areas. What explains this? Well, something that explains it is spatial heterogeneity in neighborhood vegetation. This is one factor that turns out to be quite important. Some of the hottest areas of the city are areas that have very, very little vegetation. In the future, we're expecting quite a lot of increased heat. I'm putting this up here to shock you, but also to tell you that this is one of the ways that we like to present things is in a simple way. And so we have a graduate student who does these cute little infographics. Maximum daily temperature now 113 in a year, possibly as high as 123 by the end of the century. And then we have, these are the days with minimum daily temperature above, what is that, 90 degrees, 110 days. It doesn't cool down at night. And then this is maximum temperature above 110 degrees over 3 months by the end of the century. So those are, these are the kinds of things we tell them that's happening. So we want to look at what's happening now, what's likely to happen in the future, and think about solutions to that. We can also do maps. Some people really go well with maps. So this is heat exposure, so heat in these different areas of, and this is a portion of Phoenix, South Phoenix, where we've done our scenarios. Some of our scenarios work. It's a traditionally underserved population, over 90% minority, poor, low family income, and so forth. And we can also look at the sensitivity to heat. Things that go into this metric are things like the number of people over the age of 65 and disabled people and so forth. And then we can combine those to get at vulnerability. And this is a pretty classic way to look at vulnerability. You look at exposure, you look at sensitivity. Sometimes you can look at adaptive capacity and combine those into these maps. So we can show them these maps in the workshop, but we can also show them maps like this, which are draped over, in this case, draped over a satellite image from Google Maps. And it shows the same kind of information, but it's a little bit more interesting for people to look at, and they can actually go online and zip around in this and look at different parts of the city. It's pretty standard analysis. I'll show you this one for Hermosillo, which I think is getting closer to what we really want to think about, which is how do we actually think about vulnerability in a social, ecological, and technological system? So not just the social and the exposure. So here we have a map of exposure to flooding. This is the projections for the future. And this is a map of exposure to flooding for the city of Hermosillo. We can then look at vulnerability in terms of social vulnerability, and here we have both metrics that reflect adaptive capacity, that is education level, and sensitivity. And we can map that, and you can see that map is different. But what these folks did, Vivian Verduzco, Jason Sauer, and Agustin Robles, is that they actually took a third step, which is to look at the infrastructure vulnerability. So they mapped out the vulnerability of infrastructure as a function of pipe diameter and the year of installation, so how likely that is to fail. And these are just some pictures of some failed infrastructure. But you can see that map. And then they can combine those and come up with an overall vulnerability map for the city of Hermosillo that doesn't really look like any one of these things, but incorporates all of them. So this is what we're doing for each of the cities as we develop these sort of ideas about where the vulnerable areas are and so forth. We also then look at the strategies that are sort of enumerated by the survey respondents. So this comes from the survey that we did in Phoenix. And here, what we've done is to map the 4 or 5 most frequently cited strategies onto this Venn diagram so we can look and see, are they thinking about ecological solutions? Are they thinking about primarily technological or social solutions, and are there any that are coming into this sweet spot where they're thinking about all three of these solutions? And you can see that there aren't, yet there are some that are at the intersection of two of these. So these strategies, and this is perhaps a little bit of a detour here, but the strategies that we're talking about, we're interested in, get back to this idea of risk as the product of likelihood of an event and consequence. And so we're really interested in the idea of safe to fail. So when you have failure in infrastructure, here's an example of a failure in infrastructure, you have a variety of consequences that are social, ecological, and technological. So all of those things are affected by the failure of infrastructure, or basically the failure of infrastructure. So the idea of safe to fail is that we want to design systems such that the likelihood may be higher than the 1% probability or the 0.1% probability, but the consequences would be lower. So we would reduce consequences, social, ecological, and technological consequences of an event by designing a system so that it has the capacity to be more flexible and so forth. And so here's a very cartoonish example of a contrast between fail-safe and safe-to-fail. These are both in Phoenix, in the Phoenix metro area. This is a flume that is meant to contain the 1 in 100 year flood. And you can see that it's massive and large and probably not very much of an attractive neighborhood feature, right? I think you could argue that. And this is Indian Bend Wash, John Roach, that was created as a greenbelt that would absorb floodwaters and basically just allow this whole system to fill up during floods, but it's all a series of parks and has trash cans that are chained to cement pads on the ground. So there's very little damage when a flood goes through there. So low consequence of failure. So that's the idea that we're trying to promote with these, the idea that we have these hybrid systems or ecologically based systems, nature-based solutions that are safe to fail, that are providing not only the service of protection against extreme events, but also the service of, in this case, recreation and enjoyment of nature and so forth. What? That was not good. Sorry about that. Cancel. I don't know what happened there. I'm so sorry. Discover your wine experience. Okay. All right. Okay. This is just another quick example of the ecosystem services of SET's infrastructure. This is from San Juan. And what we have here is a challenge of building resilience in a series of neighborhoods in San Juan that are surrounding this canal that's been there for quite a long time. It's a conveyance canal between San Juan estuary and another portion, the sea near the ocean, near the airport. But the idea is to enhance resilience in this area, to build resilience but avoid gentrification. I'll explain what I mean by that, but let me just show you this. It says, the canal is yours, take care of it. So people are very motivated in this environment. This is a picture of the canal, and it's surrounded by some of the poorest neighborhoods in San Juan, 8 different neighborhoods. It frequently floods, and the reason that it floods is that they haven't really done anything to care for it or dredge it out, and it's surrounded by homes pretty close to it. And so the idea of this restoration is to restore the services of this system of actually being able to convey water, but also at the same time to make it into a nice green space, move the houses back off the lot, and so that people can enjoy it and get multiple services from it. And so, this is just a metric that we have been playing around with developing that would indicate the kinds of ways in which this restoration would achieve being ecosystem-based, but also achieve the sort of ideas of equity and justice and be technologically advanced. Well, this one isn't. Have co-benefits and be effective. Okay, so given this information that we have, we embark on these future scenarios. And these scenarios are important because they're allowing people to get together and from very diverse viewpoints and articulate the visions that they may have, explore what the different alternatives might actually look like, deal with the future uncertainty, and bring people together around a common vision of the future. And the important thing to remember is that we don't know what the future is going to be, and we could make some projections, but why not think about a range of possible futures that are positive visions that people think are plausible and that are reasonable in terms of the variety of things that we've been talking about here, including safe-to-fail infrastructure, protection from harm, reduction of vulnerability, attention to equity, and so forth. And I think the capacity of the human species to actually dream and have these sort of imaginaries of what the future could be is really important. So understanding what motivates people to take the decisions that they do, how they decide whether to move or live in a city that they might have this vision and end up with this vision, or live in the countryside with one of these visions. It's what we're trying to do is sort of exploit people's capacity to imagine the future. So in each of these workshops, what we do is we start with the current and future challenge, all the things I've been showing you, the vulnerability and so forth. In the workshop, we establish a set of goals. In each goal, we establish strategies, and then we do some very detailed work on how, who should be involved, where should it happen, how should it happen, and so forth. So this is an example of a timeline developed in one of these workshops. Here's an example of some people actually putting some of the strategies that they've thought of on a map, and then we also have designers and artists sitting at the table and illustrating what they're hearing people talk about. After these workshops, we have a variety of data that are coming out of this. We have all the information about the themes and goals, strategies, and so forth that they've put together. We have various recordings. They actually make narratives at the end of these workshops where they imagine the day in the life of someone living in 2080. And so we have those narratives that we can enhance. And we try to then take these and run models, do this qualitative assessment, create visualizations, and enhance the narratives that they put together. And here's an example of a visualization put together to illustrate a strategy that might be considered for the Phoenix area. So one of the reasons we do this in a number of cities is because, well, we want to have more of an impact, but also because we want to think about how we compare cities in the future. And so we can think about these axes across which we could compare cities' visions of the future. They could be social axes, they could be ecological or technological axes. And just to illustrate some very, very preliminary ideas that we have about this, we thought, okay, let's compare the visions coming out of Valdivia, Hermosillo, Phoenix, and Baltimore. And we might say, okay, we have Latin America and North America. Those are some interesting contrasts. Or we have these two cities that are both in the Sonoran Desert. So we might expect to see some similarities in the visions that come out. And I have to emphasize that this is preliminary, but here's actually what we find. These are word clouds, again, from each of these that are based on the visions that were produced. And here's where the main comparisons come out, the main similarities come out between Valdivia and Phoenix and between Hermosillo and Baltimore. So it didn't work, right? So there's a lot more work to do to figure out what's going on. But there's a lot of richness in what we have available to us, and we're just starting to do that. We are co-developing these alternative visions of the future. Many of the cities have similar kinds of strategies and themes that they've addressed. So a lot of them, equitable city is a very, very common one. So we can do this comparison across those, and that's the kind of thing I was just showing you. We haven't started, or we have started, but we haven't really got much completed on this. But we can also look at a single city and compare across those different visions. And so I'm going to show you work from Phoenix, a regional analysis that we did. And this was about a 2-year process with several workshops in which we were envisioning sustainable future scenarios for Phoenix in 2060. This is the present-day situation in Phoenix. You're going to see more maps like this, but you can see that the orange is agriculture, the tan is desert, the green is trees, grass, and there's not very much of it in there, as you can see. The various shades of gray are different densities of urban environment. So we created 6 future scenarios co-produced with people in a workshop. The people that come to this workshop are city officials, state officials, federal. We had NGOs like the Nature Conservancy. We had some community organizations and leaders of those and so forth. And these were the 6 that we came out with. We have 3 adaptive scenarios. These are scenarios that are intended to address a particular challenge, in this case flooding, drought, and heat. And then we have 3 transformative scenarios where we're simply asking people to really think outside the box, really think, what would you like Phoenix to be like in the future? And so these are kind of the ideas associated with those. I'm going to show you data from the outputs from the adaptive drought scenario, which is called the true cost of water. It's focused on long-term water security and conservation. And the transformative scenario, which is focused on balancing targets for flood, drought, and heat. These are the outputs from the mapping exercise. So put into a GIS and codified here. So you can see adaptive drought is a collapsed density, much more high density, less agriculture, and a much smaller footprint. In the Emerald City, you see quite a lot of green, still some agriculture and so forth. So we wanted to ask, what is the consequence of this for heat in these areas? And so my colleague Matt Georgescu ran models, weather research and forecasting models on this, and this is the heat outcomes that you see for these. And so when we show people things like this is just a temperature above a baseline, right? But when we show people things like this, they can see immediately the consequences of these different types of decisions, and that's the important thing. We can also look at these two in terms of how much water banking we can do, how much we can save water. And in the adaptive drought, they're really focused on collection of water and injection into groundwater and saving, banking water, and they do quite a much better job than the transformative model on that. I'm going a little slow, I'm sorry. We also want to do this qualitative analysis, and we have 3 prongs of the qualitative analysis: assessing resilience, sustainability and equity, and transformation potential. I'm only going to talk about the resilience one. The idea here is we're using these different criteria for enhancing resilience or managing resilience in ecosystems that come from a paper by Unsi Biggs and others in 2012. And I'm going to show you 2 contrasting areas. One is for San Juan and one is for Phoenix. So San Juan had a number of different scenarios that they considered: food and energy, connected city, just and livable, coastal flooding, riverine flooding, and urban flooding. And this is just a collage of some of the pictures from the workshop. And so to think about the food and energy security, they established 3 goals: effective and reliable energy system, food distribution and storage network, and local sustainable food supply. These are the 3 goals that were established, and for each of these and the strategies that they identify, we evaluate the resilience of that. And so this is just a little flower diagram that shows you how the food and energy security scenario does. It does very well in terms of diversity. Again, remember, it's to sort of establish a stable and reliable and adaptable, flexible food supply and energy supply. Does pretty well in redundancy and connectivity and system lens, not so well in some of the other areas. If we look at all of the scenarios for San Juan, what we can see is the best scores are obtained for connectivity, slow variables, and diversity. I'm rushing, I'm sorry. So for Phoenix, this is again the South Phoenix area, and these were the scenarios that, this is the smaller, not the regional Phoenix, but the area in South Phoenix. The themes were connected and mobile, just green enough, which is really about how to enhance greenness without having gentrification occur. Equity district, some like it hot, which is about cooling. Mountain to river, which is about a unique sense of place of this area, and flooding. And here are some of the visualizations that were created. One of the really cool things we did with this South Phoenix workshop was to take those themes and all the data that came from the themes and hand it to a class. My colleague Paul Casio is a landscape architect. He ran this class, and each of the groups in the class created these visualizations and designs for the future that they were representing. So the 5 different futures. And these are just some of the pictures from that. Here's how they do those different ones in terms of the resilience criteria. So, you know, we're just starting to analyze these. Another cool thing about this is that we're going to be able to compare this neighborhood scale resilience criteria with the regional scale from the earlier ones that I showed you. Some of these don't do so well in many of the criteria, and some of them, like the cool desert city, does quite well. And interestingly, just like the San Juan scenarios, these 3 seem to be the ones that the scenarios do the best on in terms of connectivity, diversity, and flow variables. So I'm sorry I've taken so long. This is longer than I thought, but I want to conclude by again reiterating that I think that people in the world are going to be experiencing increasingly climate change through extreme events, and mostly in cities. I think that resilience is a very appropriate framework to understand the impact, but I think we have to really be thinking about the ways in which different communities are using the term resilience, and be willing to be flexible about the ideas and the meanings of that term. Also, set solutions are part of our current toolbox, and we need to expand those, social ecological. We need to expand to social ecological technological systems to think about new ways to quantify vulnerability and resilience, and to develop these positive future visions for diverse cities in the face of future extreme events. So thank you very much. I'd be happy to answer questions. Yes.
So all of your scenarios were pretty bad at adaptive management.
Yeah, you noticed that.
And I was just wondering, I mean, is that partially because of the policy or the time frame that plans are done? Like, is there something sort of said about the process of how this is done, or time frame that?
Yeah, we do have these timelines, but I don't think we're dealing very well with feedbacks, right? Mm-hmm. So what if you go off? What if you err and go off the timeline, or what if you have to make a change or something like that? I don't think our methods are really appropriate to getting at that, unfortunately. So that may be why. And one of the things we may be learning from this qualitative assessment is how well we are actually, through the activities that we have, how are we actually, shaping what's coming out of people's ideas, what's being co-produced. And we have to be aware of that and careful about it, I think. But one way we could think about that is we introduced about halfway through the process a new activity in the workshop that had to do with governance. And so it was really thinking about who has to be involved in this. This is a cool thing, by the way, that was made by Timon McPherson and his team on Manhattan, just showing some of the things that they're doing for visualization. And so, I think one of the things we plan to do with these is come back with the assessment as well as the models and show them to the same group of people, and try to sort of refine those visions. And so if we're consistently doing poorly on adaptive management, then perhaps we need to think about how we can introduce that as a new method for it. Yeah.
Morning. I'm interested to what extent allochthonous influences are relevant here, and where are boundaries set? It seems like you have some defined entity. Does that come from? I don't know. Where does that come from? How is the decision made where the city stops?
Yeah. It's decided by the participants in the workshop or some smaller subset of the people that are putting together the scenarios workshop. So that's part of the scoping and framing phase when we're trying to decide what are the themes, what kind of areas should we be focused on. Some of this, like in Phoenix, for example, we decided this with the sustainability officer, the chief sustainability officer that we work with really closely, and the city person from Nature Conservancy, because they're our sort of main people that we work with most closely. But for the themes, we decided to do those by holding a World Cafe where we had a basket of like 8 or 9 different themes, and then we had people go around and sort of riff on the themes and decide, vote with their feet about which ones were the best, and then help to refine what the themes were really about. But the boundary thing and the allochthonous inputs, hugely important in some things. Like I wanted to show the San Juan energy and food security because, well, partly because you guys are food, water, energy, but also because they were really just in a bad way in San Juan when Maria hit because, well, first of all, the electrical grid is very bad, but and is in bad shape, but also because they're so dependent on imports. And so there it's kind of island city, right? Island city, and then everything is pretty much allochthonous. And so these ideas about how we could improve the food security situation by actually having sort of multiple distribution and storage areas as well as growing our own food was a really big part of that.
So, I think it was down in Chile, you had this sort of interesting way of looking at risk and overlaying different sorts of risks to come up with a new map of what was vulnerability.
Yeah.
And I think it's really powerful. I also could see it being twisted for poor uses. In particular, people taking advantage of this to identify places that they might want to flee or pull investments or raise insurance rates and the like, and really sort of exacerbating some of those equity issues that you're trying to address.
Yeah, I mean, we're putting those maps out there specifically to address those equity issues, but you're right. It could be taken and used in the actual opposite way. I think that's always a risk when you create maps of anything, that somebody could use it in the wrong way. I can say that, well, we have the right people at the table, the people that are making decisions about, where they're going to put improvements in the city, and they are very concerned. A lot of our practitioners are very concerned about equity. When you're going to improve, when you're going to put in a new improvement or say lots of green infrastructure or something like that to combat flooding, who gets it, right? And who gets to decide where it goes, and then who's responsible for maintaining it, and things like that. And those are some really big issues that people have in cities. But I take your point. I'm just not sure what exactly I could do about it. I would like to put more things on there. I mean, I would like to have ecological variability more, or vulnerability more on there. And they're working on it, but it's it's sort of slow going.
Don't get me wrong, I think it's a great tool.
Yeah, you think you're right, though. Yeah, Corey.
I don't want to be the only person, or the only faculty member in my row who doesn't answer.
Pressure, Lisa.
I was struck by the lack of similarities that you were hypothesizing you might find between the desert cities versus North and South America.
Yeah.
So is it really just context dependent? independent, do you think, or are there some things that...
Well, which context are we talking about, right? So there's a lot of things that go into context, and that's, you know, in ecology, we, you know, it's sort of wildland ecology, we just think about the biome that we're in, maybe, and that's about it. But that's context that's important, or how close we are to a city, or something like that. But in cities, you know, you've got all these things that are the context variables. That's it, talking about those axes. You've got social cultural axes, you've got, you know, financial, economic, you've got all the biophysical stuff, and you have, you know, how advanced a city is technologically. So I just think we didn't choose the cities in the network to be specific comparisons. We just chose them because we had to get a network together really quickly, and these were the people we knew. So, you know, the thing is that we're going to try to explore how we can pull those things out, and that's just the top, I don't know what it was, 6 terms or something like that. I mean, there's a lot more information and ways to do a content analysis on these visions and really try to pull out some of the differences. And we're kind of right now we're discussing hypotheses about, you know, which variables are going to be most important in determining differences, and so then we can go in and do these analyses and test those hypotheses. Yeah.
Time for one more question.
And let's encourage that to be from a student.
In a different room.
I have a question. It just seems your community involvement participation seems high. Can you elaborate on the type of workshops and how you're bringing in community members to participate in planning processes?
So I talked earlier today about some community focused workshops that we're doing on heat action planning. This system that I talked about that we're doing in the 9 cities is focused on decision makers, and so the extent that community members are able to be participants in it is really through like community activist organizations and the leaders of those organizations and so forth. So, for example, we have in Phoenix we have Chispa involved in it, and we have Interfaith Power and Light, which is a faith organization that's concerned about climate change. And those are more community organizations, but in terms of members of the public or community members, that's not focused on them. And this is always a point of friction between me and my postdoc, who really wants to be working directly with community members. So she's doing a lot of stuff with community members, but it's not what I presented here. Yeah.
All right, well, thank you everyone for coming, and there is somewhere out there, or over here, there's food for reception, and you can ask some additional questions of Nancy after that, and so join me in thanking Nancy for...